Next type of graphical entity that's a little bit more complex than lines are what's called parabolas. Now, parabola is a word that means the graphical description of a quadratic equation. So you're looking for something of the form ax squared plus bx plus c, where a, b, and c are any constants, and a just cannot be 0 because having the x squared is the determining factor in something being a parabola. So parabolas are always symmetric about their vertex. So, for example, no matter where the parabola is placed on the graph, if you know where the point of it is, it's always symmetric through that vertical line. And it always curves in an x squared relationship. So these are not lines, these are curves that change slope as you go along them. So another way that you can write a parabola is in what's called the general form of a parabola, which looks like this. X So you might think that looks somewhat similar to our circle equation that you have h and k. In this case, h and k don't stand for the center because there really is no center on this type of graph. What they stand for is the vertex. So hk are the coordinates of the vertex of the parabola, and this is equal to y. Y equals that. So you can see x and y are, again, just any point on the parabola, and a is a factor that tells you how steep it is, essentially. But if you're given this vertex and any other point, you can always figure out the exact form of a parabola by plugging in the vertex, plugging in that point, solving for a, and then you can expand this to get it into this form if you want to. So the equations of the parabola are essentially dependent mainly on the vertex. And we're going to get into vertex formula in a different video. But knowing that a quadratic equation always gives you a parabola is very handy information. Now the other thing I want to point out is that since parabolas are always symmetric about their vertex, say we had a function in general, instead of ax squared plus bx plus c, let's say it was something that was easily factorable, like, let's see here, we could pick something like, I don't want to factor it just yet, x squared minus 8x plus 15. You can probably see that this factors into x minus 5, x minus 3, which means that you have zeros at 3 and 5. So if you were going to graph this, you know that at 3, the graph has to be on the x-axis. And at 5, the graph has to be on the x-axis. So, what you know is that if those 2 points are certainly on the graph, that means that the vertex has to be right in the middle of those two. So you don't know where it is vertically, but you know that that vertex has to be at 4 in this case, because it has to be right in the middle of those two. The other thing you know is that since this coefficient, this a, in front of the x squared, in this case it's just 1. The important distinction here is whether it's positive or negative. If it's positive, you're going to have a parabola, so if a is greater than 0, you have a parabola that opens up. If a is less than 0, if a is negative, you have a parabola that opens downward. So these are just some other things that can help you define what a parabola might look like. But remember that their basic shape is of a quadratic equation, and using the general form is handy if you know something about